Welcome back, Algebra 2 students. Part 2, section 10-3, the unit circle. Guys, in this part, we're going to do example number 3 and example number 4. Remember, guys, in example number 2, we have used the unit circle in order to evaluate the trigonometric functions, and it was kind of challenging to memorize all the unit circle. Guys, in example number 3, we're gonna find the trigonometric functions, but not using the whole unit circle, by using the reference angle. Remember, guys, the reference angle is the angle between or formed by the terminal side of any angle and x-axis. So it's definitely in quadrant 1. The reference angle is in quadrant 1. So we're gonna only focus on quadrant 1 of the unit circle. Guys, but the signals or the signs of the trigonometric ratio depends on the quadrant. So if your original angle is in a different quadrant, you have to be aware of the sign of this trigonometric ratio in that quadrant. This is why I have this diagram, and you need to memorize the signals of the trigonometric function sine, cosine, and tan in all quadrants. Guys, in quadrant 1, the sine, cosine, tan ratios are positive. Why? Because x is cosine theta, x is positive, and y is positive, and the tan is the ratio of sine over cosine or y over x, so it's going to be positive. In quadrant 2, the y is still positive, but the x is negative, cosine is negative, and tan is the ratio positive over negative, it's going to be negative. In quadrant 3, sine and cosine are negative, and the tan is positive because negative over negative is positive. In quadrant 4, the y is negative, so this is explains why sine is negative, and cosine is positive, cosine is x, and the tan, the ratio of sine and cosine, is going to be negative. If you memorize this, we can use the reference angle as a new strategy to evaluate the trigonometric functions. Take this example, guys. Using reference angles to evaluate trigonometric functions. Use the reference angle to find the exact value of sine, cosine, and tangent of the angle 330. Guys, step number 1, we find the reference angle of this angle. Let's consider this side the initial side of that angle. And because it's positive 330, the rotation direction is counterclockwise. So definitely this side is the terminal side. And the reference angle, this is the reference angle theta, is the angle formed by the terminal side and x-axis. So it's going to be, remember guys, one complete round is 360 minus 330. It gives us the reference angle measure is equal to 30 degrees. Now, guys, we can handle this with the angle, the reference angle 30 degrees. We can find sine 30 because it's easy. Everybody knows what is sine 30. It's from quadrant 1. Sine 30 is half, and cosine 30 is equal to square root of 3 over 2, and tan 30 is equal to square root of 3 over 3. This is the trigonometric ratio sine, cosine, and tan of angle 30 in quadrant 1. But wait a second, guys, our angle is not 30, our angle is 330, and this angle is located in quadrant 4. In quadrant 4, now guys, we can personalize the signals of these angles. We can adjust them, so we can find sine 330 and cosine 330 and tan 330. Remember, guys, the sine ratio in quadrant 4, 330 is in quadrant 4. The sine ratio is negative because we are underneath x-axis, so the y is negative, so sine ratio is negative. So we're gonna copy sine 30 value, which is half, with a negative sign, so it's gonna be negative half. Cosine is positive in quadrant 4, so we're gonna take the exact value of cosine 30 because cosine is positive in quadrant 4, so it's gonna be square root of 3 over 2. And the tan ratio in quadrant 4 is negative, so it's going to be negative square root of 3 over 3. So in that example, guys, you learn how to use the reference angle in order to evaluate the trigonometric function of any angle using the reference angle and using the signals of the different trigonometric ratios in all quadrants. Another idea, guys, in this section, the arc length formula. Guys, if we have a circle and we have a central angle theta in a circle with a radius r, we can figure out the length of the arc opposite to the central angle theta. The length of this arc is given by the formula S equals r times theta. S is the arc length, r is the radius of the circle, and theta is the measure of the central angle, and this measure has to be in radians. It can't be in degrees. How do we use that formula? Look at this application, guys. A tire of a car makes 653 complete rotations in 1 minute. The diameter of the tire, guys, we can visualize our problem, so we can draw a rough graph. This is our tire and this is the diameter of the tire. The diameter of that tire is 0.65 meter. But wait a second, guys, we're not using the diameter in any kind of calculation. We're always using the radius r. So it's a good idea to start with finding the radius of the tire. So the radius of the tire is equal to the diameter 0.65 divided by 2. One diameter is equal to 2 radii. So guys, if you divide that by 2, you will get 0.325 meters. This is the radius of the tire. And now, guys, back to the problem. The diameter of the tire is equal to 0.65 meters. To the nearest meter, how far does the car travel in 1 second? Guys, we're looking for the horizontal distance the car travels in 1 second. So guys, my strategy is to find this horizontal distance by finding the arc length of the whole tire. The arc length of the whole tire can be found using the formula S equals r times theta. Remember, guys, we are trying to find the horizontal distance traveled in one rotation. Later, because this car travels, or this tire makes 653, I'm going to multiply this distance times the complete number of rotations. So let's focus now on finding this horizontal distance for one complete round. If this tire rotates one rotation only, what is going to be the horizontal distance? The horizontal distance can be found using the formula S equals r times theta. Guys, our r, we just found our r, it's 0.325. And remember, guys, we're trying to calculate the horizontal distance in one rotation. One rotation, it means times 2 pi, because it's a complete round. Complete round in radians is equal to 2 pi. So our angle theta is equal to 2 pi. Guys, I'm not going to evaluate this. I'm going to evaluate after I finish step number 3. So in step number 3, guys, we need to figure out the distance traveled in 1 second. So guys, how do we find that distance traveled in 1 second? Please focus on the following step. Guys, we're gonna take the horizontal distance traveled in one rotation. This is one rotation. It's 0.325 times 2 pi in radians. Okay, this is the horizontal distance traveled in one rotation, but that tire makes 653 complete rotations. So I have to multiply this times the number of complete rotations, 653. And guys, the tire makes this number of complete rotations in 1 minute. And I need to figure out the distance traveled in 1 second. So I have to divide the whole thing by 60, because you know, guys, 1 minute is equal to 60 seconds. So guys, if you put all of that in the calculator, you will find the horizontal distance traveled by this car in 1 second, and it's gonna be 11.76 meter. Pretty nice problem. Practice well, guys, and see you in the next lesson. Bye.